look at what happens here. So you have this changing, the symbol changes. Then you have this divided by minus 7. So automatically this one cancels this. You have x less than, this is 5. That's minus 5. If you want to also represent this on the number line, it is also, let's say this is your point 0. Then let's say this is your minus 5. Point minus 5. Just take it up and you take it like this. So this is x less than minus 5. So that is the symbol representation on the number line. Let's see the next example. The next example is into 2. The first thing is A. Solve the inequality. Solve the inequality. 11 minus 2A is less than 4. 11 minus 2A is less than 4. You have to solve the inequality. B. Given that A is an integer, find the 3 lowest possible values of A. Given that A is an integer. When you say a number is an integer, that means it does not have a decimal part. It's a whole number without decimal part. So here, we resolve this by collecting like terms. Then this one comes together like minus 2A less than 4 minus 11. Then here we have minus 2A less than minus 7. So we divide both sides by minus 2, and when we divide this, the less than sign, it becomes greater than sign. You have minus 2A divided by minus 2 minus 2. So this minus cancel this, minus 2 cancel this. You have this. This cancel this. So you have 3 whole number 1 over 2. It has been, we calculated our A to be greater than 3 whole number 1 over 2. And our A has been stated in the question. So the question A, this is the answer to the question A. But in the case of question B, an information is given to us that the A is an integer. Automatically, we have, it will start from 4, 5, 6, 7, 8, to n. That's what A will be since it's an integer and it's greater than 3.5. So automatically the question asks us to look for the 3 lowest possible values of A. From this setup, the 3 lowest possible value of A will be this, this, and this. So A will be 4, 5, and 6. So these are the 3 lowest possible values of A. Example 4. What is the range of values of x for which 2x plus 5 greater than 1? 2x plus 5 greater than 1 and x minus 4 less than 1 are both satisfied. So since they want us to determine the value of x in the respective cases for which the range of value of x are both satisfied. So we have to solve this separately. So solution now. We have 2x plus 5 is greater than 1. So automatically collecting like terms here, you have 2x greater than 1 minus 5. And that means your 2x is greater than minus 4. Divide both sides by 2. Divide this by 2 and divide this by 2. Automatically we are going to have x greater than minus 2. So when our x is greater than minus 2, that's the first case. Then let's see the second case. X minus 4 less than 1. So when you collect like times here, x less than 1 plus 4, and our x is less than 5. So we have 2 cases now. The first case on the number line, our 0 region. This is our minus 2 region. We have our x is greater than minus 2. Then the second one, we have is our 0 region. So this is our 5. Then our 5 is less than x. So we have it like this. So we want to know the range of values for which x is satisfied. with respect to this inequality. You see that this is facing this, and this is facing this. Automatically, if you join both on the same line, which one is -2? So this one will be facing this side, so they collide. And since they collide automatically, that means they have a link. And since they have a link, then it will definitely be -2, because your x is greater than -2, implies that -2 is less than x. Can be written that way. Then the second one, your x is less than 5. So what is connecting both can now be -2 less than x less than 5. So this is the range of value for which the inequality will be what? Satisfied. Then we have some other examples. State the range of values of x for the graph in figure 11.1.1. Look at this graph. We are asked to state the range of values. We can see that this one is disjoint now, and that is the significance of doing logical reasoning before linear inequality. This one is conjunction, and this one is disjunction. So here our x is less than -1, and here our x is greater than 4. So they are both disjoint, so they will go separately. X is less than -1 and x is greater than 4. Exercise. In this exercise, we are asked to state the range of values for which x is satisfied in the inequality. If you look at what you have in both cases, we see that the circle here is painted, and this one is also painted. When both are painted this way and you have a link, automatically what it's saying is that you have a less than or equals to sign, and this one, that means your x is ranging between this. So automatically, if you are to write this, it will be, for the a part, you have -1 less than or equals to x less than or equals to 3. So that is the range of value of x in that a. The big case, this one is shaded, and this one is not shaded. Automatically, it will be -7 less than or equals to x less than or equals to 7. So that will be the range of value for x, because you have a conjunction here. They are linked here. They are also linked here. Here they are not linked. They are disjoint here. So automatically we have this one is shaded and this one is not shaded. So automatically x will be less than or equals to 5 for the C part. Then x is greater than 0 because this one is not shaded. So those are the respective answers for those graphs. Exercise. Solve question number 1. Solve the inequalities and sketch the graph for each. You have A. We have 4x minus 1 less than or equal to 7. Then B. We have 5x minus 1 over 3 minus 1 minus 2x over 5, which is less than or equals to 8 plus x. And in C, we have 2 over 3 minus 3x, 2 over 3 minus 3x, which is less than or equals to 2 into 1 minus x. It's the first case. So solution to this now, we have 4x minus 1 less than or equals to 7. So we collect like terms. We have 4x less than 1, less than or equals to 7 plus 1. And that will be 4x is less than or equals to 8. Dividing both sides by 2, we have 4 divided by, dividing both sides by 4. We have 4 divided by this, we have x less than, 4 divided by this, we have 2. And representing this on the number line, let's say this is our 0 region and this is our 2 region. So we have this, that will be shaded because of the fact that it has this, then goes like this. So that is the graph of that question A. Question B, we have this scenario. So the first thing we do here is to look for the LCM. Very important. And the LCM here is 15. So we multiply each term by the LCM. Multiply this by 15, multiply this by 15, multiply this by 15. So that will be 15 times 5x minus 1 over 3 minus 15 into 1 minus 2x over 5 less than or equals to 15 into 8 plus x. So 3 here 1, 3 here 5. So we have 5 into 5x minus 1 minus 5 here 1, 5 here 3. So I'm minus 3 into x minus 2x less than or equals to 15 into 8 plus x.